Hello, my friends. In this video, I'm going to talk about a very interesting topic in all programming languages and especially in Kotlin. It's called the function. A function is a block of code which only runs when it's called. You can pass data known as parameters into a function. Functions are used to perform certain actions, and they are also known as methods. Let's start by understanding these functions, and I will show you a very good example that you used the functions in the previous videos. So it turns out you already know what a function is. You've been using it the whole time through this course. Yes. For example, the println method or print method. Here, I will display a message telling, hello, my friends. If I run it, it will display for me the message here. So, println is a function. It's used to output, to print the text to the screen. So, this is a very good example about functions. And by the way, it's a predefined function. It's included inside the JDK and the Java development kit. Okay, so this is a very quick example about the methods. Okay, now let's create our own functions. To create your own function, use the fun keyword and write the name of the function followed by parentheses, and you can specify later on the parameters. But till now, I want from you to focus with me in order how to create our function. We start by the keyword fun. Okay, and you specify here the name of the function. My first function. I will name it as like this. And here we put the parameters. In the next lesson, we are going to see this in action. Okay, and these are the parentheses, and these are the curly braces that defines the beginning of the function and the end of the function. Here you put the code to be executed when the function is called. Let me put println your first function is called. Okay, this is the structure of the function. We start by the fun keyword. Please write this down, guys, on your copybook and your notebook. Fun keyword is used to define a function. This is the name of the function followed by the parentheses and the curly braces that defines the beginning and the start of the method and the end of the method. Here you put the block of code that you need to be executed when the function is being called. Okay, this is the simple understanding of the method. Okay, now in order to call a function, if we run the program now, it will not make anything because we didn't call the method. And if we hover on this method, function, my first function is never used. So Android Studio will make it like this gray and gray color, and that indicates that it will not be used in the previous codes. Okay, so you are not using this function any more. In order to call the function and make it easy and to be understandable, and to make the function functional, not like this program. If we run it, there is no function to this. There is no role of this for this function. In order to make it running and make it functioning well, we need to call the method. We have created now this function. To call the function, write the name of the function followed by 2 parentheses. Going up to the main function, we call the methods here, and we type the name of the function, my first function, followed by the parentheses. Okay? If I run the program now, it will give me a message, your first function is called. So we have run this function by calling it inside the main function. Okay? We can call the function multiple times, so I can paste it like this 3 times. If I run it, it will give me 3 lines telling us that your first function is called. Okay? This is about function creation and calling. Just one notice I want you to understand. If you see that when we call the method my first function, the color here in the IDE is changed from gray to yellow. So this will indicate that my first function is used. If I remove the calling of my first function, the color of this will be changing to gray, telling us if we hover the mouse, it will tell us the function is never used. Okay? These are some tricks, these are some hints Android Studio and this IDE will give to you. Hello my friends. In the previous video we have learned how to create and call a function. In this video I'm going to talk about function parameters. Information can be passed to functions as parameters. Parameters are specified after the function name, inside the parentheses. You can add as many parameters as you want. Just separate them with a comma. Just note that you must specify the type of each parameter, either an int, string, and other types. Let's see an example about function parameters. This function that we have created before, I will start making like this. First, name, 2 points, and string. Okay? And here, I will put hello, and I will call fname. Okay? There is an error here if you notice that no value passed for parameter fname. This example, I am passing if a parameter of type string called fname to the function my first function, and when the function is called, we should pass along the first name, the fname parameter, which is used inside the function to print the full name. If I run the program here, there is an error because I should specify the fname, the first name, the parameter of type string. Okay? So here I need to pass hello Jack. So I pass the first name Jack. It will print for me hello Jack. If I run it, you can see that it is using the Jack string as a parameter, and we typed hello Jack successfully. Okay, this is the function parameter. When a parameter is passed to the function, it's called argument. So we call Jack as an argument. So I want from you to concentrate and to differentiate also between 2 concepts. When the parameter is passed to the function, it's called argument. So Jack is an argument and fname is a parameter. Okay? We can pass many parameters as you like. So I will pass here age. It's of type int. Hello fname plus your age is your age is, I am calling age here by concatenation operator, the plus sign. Okay, here there is an error because I need to pass the second parameter, so I will pass 28. If I run the program here, it will give me, hello Jack, your age is 28. Okay, you see how the function parameters works and how to pass multiple parameters. When working with the multiple parameters, the function call must have the same number of arguments as they are parameters. So I have two parameters, the string and the age of type int. I need to pass two arguments, one of type string and one of type integer. And the arguments must be passed in the same order, of the same type and the same order. I can't pass 28 at first and then Jack, okay? Like this. It's wrong. I need to pass the same parameter with the same order. Hello, my friends. In the previous video, we have learned how to create functions and how to pass parameters to them. In this video, I'm gonna show you how to create a function that returns a value. To return a value, use the return keyword and specify the return type after the function's parentheses, int, string, and other types. Let's take an example. Here, this is an ordinary function that it's of type void that will not return anything. It's just print the name and the age. I will create a function, fun. I will name it as add two numbers, and I will pass the first parameter of x of type int and the second parameter y of type int. And here we specify the code block of this function. And the returning type, we should put 2 points, this is the column, and we should specify the type of the returning type after these two parentheses. So it will return for us an int. You see, guys, that there is an error here that tells us a return expression required in the function with a block body. So we need to put a return statement that will return. So when we call this function will return a value of type int. For example, return x plus y. Okay, this function will be adding two variables. Okay, I will put it like this in order to see it more clearly. Now, let me call the function in the main method. Again, in the main method, add two numbers. I will add 5. This is the x and this is the y7. Please don't write x here and don't write y. These are hints automatically generated by the IDE, by Android Studio. So just put 5. Okay, it will be generating for you these hints. So just put 5 and 7. It will generate for you these two hints. Don't write x 2 points or the column 5 and y column 7. Please don't write them because many people asked me these questions. If I run the program here, it will call the function add two numbers. Okay, and it will make the calculations. But here, if we see that there is no display for the results, I should store this value of type int, the returning value of the addition of 5 and 7 into a variable. So I put here var result equal to add two numbers. Then I start by printing the result. Okay, so I stored the result of addition of two numbers inside a variable called result, and then I printed. Okay, if I run the program again, it will give me the result of addition 5 and 7. If I check 666, if I run it, it will give me 673. So our calculator is working fine. Okay, so this is about the returning values of functions. There is one note. I should mention it, but we will not use it many in our projects. There is also a shorter syntax for returning values. You can use the operator equal instead of return without specifying the return type. Kotlin is smart enough to automatically find out what is. So I can make like this, and despite using the return, I will put equal. If I run the program, it will give me again the result. So I put directly equal in, or it's just a shortcut and a shorter syntax for the return values syntax. Hello, my friends. Now let's move to OOP. OOP stands for Object-Oriented Programming. Procedural programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both data and methods. Object-oriented programming has several advantages over procedural programming. OOP is faster and easier to execute. OOP provides a clear structure for the programs. OOP helps to keep the Kotlin dry, don't repeat yourself, and makes the code easier to maintain, modify, and debug. Don't repeat yourself or dry principle is about reducing the repetition of code. You should extract out the codes that are common for the application and place them at a single place and reuse them instead of repeating it. OOP makes it possible to create full reusable applications with less code and shorter development time. What are the main OOP concepts that we are going to cover in this section? The classes, the objects, the constructors, the class functions, inheritance, polymorphism, encapsulation, interfaces, and abstraction, and other topics and concepts. So these are the main OOP concepts, and I will see you in the next videos. Let's try to understand the OOP because it's very important and it's the core of our programming skills later on. Hello, my friends. Let's talk about classes and objects. Classes and objects are the two main aspects of object-oriented programming. So a class is a template for objects, and an object is an instance of a class. When the individual objects are created, they inherit all the variables and methods from the class. I want from you to concentrate with this picture. The class, it represents as a blueprint or a template for objects, and an object is this car, this red car. We can make another object, which is the green car. We can make blue car. These are different objects, but the class is the same. It's a blueprint. It's a template for objects, and an object is an instance of a class. Everything in Kotlin is associated with the classes and objects, along with its properties and functions. For example, in real life, a car is an object. The car has properties such as brand, weight, color, and functions such as drive and brake. This is a very important concept I want from an example, and I want you to memorize well. So, Again, properties such as the brand, the way, and the color of the car, and the functions such as drive and brake. To create a class in Kotlin, we use the class keyword and specify the name of the class. Here, I will go and open the project tab. Then I will go to the Java. Here, I will go to the package, click on new, and I will go and create a new Kotlin class. I will select the class, not file, and here I will specify its name. I will name it as car. So this is the class car, and I can now specify here the properties and the behaviors, the attributes and the functions. I want from you to memorize and differentiate between two things: the attributes and the behaviors or the functions. Okay, we will see them in deep later on, but I want from you to concentrate with me and write these notes on your copybook and notebook. A property is basically a variable that belongs to the class, attributes or property. Okay, these attributes, they are variables that belongs to class. They are variables that belongs to the class. Please, guys, write these notes and these comments on your copybook and to memorize them fast. Okay, the functions, they are the behaviors that we specify for the class and how it will act and what is the job of this class. Okay, so we create a class by specifying the keyword class at the beginning, and you can specify the name of the class here. You can also make like this inside the file, hello Kotlin, but I prefer making standalone classes because it's easy to maintain. Okay, so it's good to know it's considered good practice to start the name of a class with uppercase letter for better organization. Okay, this is the car class. Here I can specify the attributes, and here we can specify the functions. Let's start by making some attributes, by defining some attributes for this car. Var brand equal to I will make Ford cars. At the var model or year equal to 2023, and I will specify the var of make a variable of a color, so color equal to red. I will make red cars of Ford brand. Let's define some functions for this class. Fun, drive, I will just print ln, a message telling us that I am driving. Okay, I can define another function called brake. It will also display a message telling us that I am braking. I am making a brake, pressing the brake. Okay, so we have three attributes, three variables that belong to the class car, and we have two functions that behaves in the car class. This is how we create classes. In the next video, we're gonna talk about how to create objects and start using these attributes and call these functions. Hello, my friends. In the previous video, we have learned how to create classes, how to create their attributes, and how to create their functions. In this video, we're gonna talk about the objects, how to create objects of classes, and how to use their attributes and functions. Now we can use the class named car to create objects. Let's create an object of the car. As we said before, the class is a template and an object is an instance of the car or the class. Okay, so I'm going back to hello kotlin.kt file. I'm going to make an instance of this class. We start by var c1 equal to car. Okay, this is how we create a car c1 object of a car class. Okay, this is the car. You see its color changed from gray to white because we have used it here to create an object. Now, this is, let me make a comment here. Please, guys, write these notes, these topics, these comments into your notebook because they are very helpful to memorize everything in Kotlin later on. I'm creating an object C1 of the car class. We initialize it in Kotlin like this, var, the name of the object, the assign operator equal, and here is the class name, and we specify the constructor. In the next videos, we are going to talk about constructors. Okay, now how to access the attributes and the properties of the objects. We said that we have three variables, three attributes, the brand, the year, and the color. Here we can access the attributes by using the dot syntax, just like we did to access array and string properties. So we specify the name of the object, we put the dot here, and we get the three attributes, the brand, the color, and the year. Okay, so I need to print the year. Okay, so what I need to make, I need to put print, and let me run the program now. It will give us the year 2023. And here we go. This is 2023 because we have created an object having the three attributes, the brand, year, and the color, as just as we specified it in that class. Because the C1 object is an instance of this template, this class. If we need to access other attributes, we can see the brand. We can see it's a Ford. Okay. Also, if you want, you can change the attributes. So how to change it? I will put c1.brand equal to the new value, which is BMW. Okay, let me run and see. Now the object C1 has the brand attribute BMW, not Ford. So it's initialized by Ford, then it's changed to BMW, and then when we print it, it will give me BMW. This is how we access the attributes and how to change some properties. But later on, we will see that this is not used in a clean architecture with a professional coder and professional developer. So we learn about something called encapsulation. Okay? But I want from you to understand this very well till now. Okay? Now, just I want to mention how to access the functions of the object. We specify C1, the name of the object, and just like before, what we did in the properties, we specify the dot syntax. If this panel or this menu disappear, please click on Control and space. Control and space to get this menu when we have a dot symbol. Control plus space, and you see there are two methods, the break and the drive methods. Let me call the break. If I run it, it will give me BMW, the name of this, and here we have breaking. Let me make it more clear. And here is breaking because I called the method break. This is how we create the object, how to access the properties, and how to access the function. In the next videos, we're going to talk about constructors, class functions, inheritance, and the encapsulation concept. Hello, my friends. In the previous video, we created an object of class and specified the properties inside the class. Just like this, brand attribute is assigned to BMW value. So, in Kotlin, there's a faster way of doing this by using a constructor. And by the way, this is not a line of code of a professional developer. This is not a clean architecture, not a clean coding. This is not accepted in modern companies and modern programs. This is just for demonstrating how to access the properties. Now, we are developing our skills in order to become more and more professional. In this video, I'm going to talk about constructors in Kotlin. A constructor is like a special function, and it's defined by using two parentheses after the class name. You can specify the properties inside the parentheses just like passing parameters into a regular function. The constructor will initialize the properties when you create an object of a class. For example, this class Ka has 3 attributes: the brand, year, and color. And since it's a template, not all the instances of a Ka contain the brand as for the year 2023, color equal to red. These are for this specific template, and these are values. So values are susceptible to be to change and become more and more variant. These are variables. How not to define these when we make a class? For example, if I have a class Ka, brand Ford, year 2023, but the color equal to green. So should I create a class car green or car 2 that contains a color green? No. Please pay attention with me. I'm going to use constructors. How to create the constructors here? Constructor. Okay, so when you create the class, you need to pass, as I told you, it's like a regular function. You can pass the parameters here. Okay, so we start by var brand. I don't need to specify this this as a Ford here. Maybe it's BMW, maybe Mercedes when we create an object of a car. So I need to remove this. Okay? It's of type string. We put comma between the attributes. Var, I can go to next line by print and tab. Var year 2 points or a dot. It's of type. Let me make it as of type integer. Okay, integer is good. It's of type integer, int, sorry. And here I will create a var color 2 points, 2 dots, and it's of type string. Okay, so here, since we have these 3 attributes with the same name, I can change and remove this. Okay, so by this, I have created the constructor. It's easier to specify multiple objects of one class. So the constructor will initialize the properties when you create an object of a class. Let me show you. If we go back to the main function in the Hello Kotlin, if we look here, there is a red error. If we hover, no value passed for parameter brand, no value passed for parameter color, no value passed for the parameter year. So we need to pass the values. Here we can specify the brand. Just guys, I want from you to understand that I don't need to write brand. Okay, I need to specify directly the two codes, and we put the value of it. Here, since we have string int string, and we have learned before, in order to pass the parameters, we should pass them in the same order with the same type. So we start by the string for the brand BMW. The second, I separate it by comma. The year is 2025, and comma, we need to specify the color. And here is a hint that shows us that we have 3 parameters. The first one is the string, the second is int, and the third is a string. So the color is gray. Okay, here I have created an object of a class car, specifying the properties BMW as brand, 2025 as year, and gray as a color. Okay, and it's even easier to specify multiple objects. So if I need to create a var c2 equal to car, and I specify here the brand is Ferrari, I put 2020, and the color is red. Okay, so I have created 2 objects with different attributes. Okay, so if I want to access the c1.brand and call the function break, I can make it as before. So if I run the program, it will give me the brand of C1, which is BMW, and I call the function break and telling us that it is breaking. This is how to create variables and using the constructor, and how to create a constructor inside the class that you made. Okay? Hello, my friends. In this video, I'm going to talk about inheritance. Inheritance is one of the key features of object-oriented programming. It allows user to create a new class, derived class from an existing class, base class. The derived class inherits all the features from the base class and can have additional features of its own. Let's take an example about inheritance and why we should use the inheritance and how to see the power of inheritance. Suppose in your application, you want 3 characters: a math teacher, a football player, and a businessman. Since all of these characters are persons, they can walk and talk. However, they also have some special skills. A math teacher can teach math, a football player can play, a businessman can run a business. In each of the classes, you would be copying the same code to walk and talk for each character. Problem. So what is the problem? If you want to add a new feature, eat, you need to implement the same code for each character. This is duplication of code and the errors will exist. So the inheritance is the key. It would be a lot easier if we had a person class with basic features like talk, walk, eat, sleep, and add special skills to those features as per our characters. This is done using inheritance. Before inheritance, if we look back to the classes, we see that the teacher class has the 3 functions: the walk, talk, and teach. The player class has 3 functions: walk, talk, shoot. And the businessman class: walk, talk, and run a business. You see, guys, I am duplicating the same function: walk, talk, for player, teacher, and businessman. So if we add the eat feature, I need to duplicate the code for the teacher, player, and businessman and add it to these 3 classes. Okay? Using inheritance, now you don't implement the same code for walk, talk, and eat for each classes. You just need to inherit them. For the math teacher, the derived class, you inherit all features of the person basic class and add a new feature, teach method or teach math method. This is the person class. I put here the walk and talk methods since they are common between the teacher, player, and the businessman, and I will inherit them from my person class. So this teacher or math teacher, the derived class, please guys pay attention for the naming, the nomenclature. Derived class or the children or the child class. You inherit all features of the person or the base class or the parent class or the super class and add a new feature, teach math for the teacher class. You see, guys, think about inheritance. We are making the common and getting the common methods, the common things, and we put them into a one big class that all children will inherit from it. This makes your code cleaner and understandable and extendable. This inheritance, this is a very important topic, and this is very important concept. You should concentrate on it. It's important to remember when working with inheritance, each derived class should satisfy the condition whether it is a base class or not. In this example, the math teacher is a person. Football player is a person. The businessman is a person. This is the relation called is a. This is inheritance. Is a. So this is the power of inheritance. We make a group of common things, common functions in one class, like person here, and we can derive these from the person, from the superclass, from the parent class to the subclasses, to the children, or to the derived classes. These are keywords. These are the naming of things in Java, super and sub. parent and children, base and derived classes. I want from you to understand them and be familiar with this. Let's take an example, another example about inheritance. Suppose that there are 3 types of employee in a company: web developer, an iOS developer, and an Android developer. All of them have some shared features like name, age, and also have some special kind of skills. First, we create 3 classes individually, and all employees have some common and specific skills: the name, and display the name and the age of the employee. But there are special skills like the web developer, web dev, can make code HTML, can execute or can create a code in HTML, while iOS developer can create code iOS, and Android dev can execute code Android method, which creates an Android codes. Here, all of them have some name and age, but the development skill of these 3 developers are different. In each of these classes, we would be copying the same code for the name and age for each character, right? Yes. So the problem is, if we want to add a salary feature where all these developers can share this feature, we need to copy it in the same code in all 3 classes. This creates a number of duplicate copies of code in our program, and it will likely lead to more complex and erratic code. The solution comes with the inheritance. So by using inheritance, the task becomes easier. We can create a new base class called employee, which contains the common features among these classes: the web, iOS, and Android developers. These functions are the name, age, and salary because they are common. These 3 classes can then inherit common features from the base class and can add some special features for their own. We can easily add the salary feature without duplicate copies in the employee class. Here, for web developer, we inherit all the features from the base class and its own feature website in the class, or code HTML in this class. Similarly, we can do the same for the other 2 classes, Android developer and iOS developer. It makes our code more understandable and extendable. So I hope you understand inheritance theoretically. In the next videos, we will see inheritance in coding and see in live with using our IDE, our code. Hello, my friends. In this video, I'm going to show you the power of using inheritance. Why should we use it and when? Suppose in your application, you want 3 characters: a math teacher, a football player, and a businessman. Since all characters are person, they can walk and talk. So I will start creating 3 classes, one for the teacher, Kotlin class. I will name it as teacher. And this teacher this teacher class has the var name, or I can pass them into the constructor. Var name of type string, okay, and var age int, okay. Since all the characters are persons, they can walk and talk. I will create 2 functions, 2 methods for all the for all the classes, for the teacher, the football player, and the businessman. So I will make fun talk, and I will print ln a message telling that the teacher, and here we can use the template name, is talking. Also, I will create a function here for walking, walk, and the same thing it will do. Okay, the teacher name is walking. Again, I will copy these functions. I will create a new Kotlin class. I will name it as player, and this player took to the parameter var name of type string and var age int. Okay, and these are the functions here, the player and the player. Okay, and the same way for the businessman. This businessman took into the parameter for creating the constructor. Sorry, I have created a Java class. Sorry, I need to create Kotlin class businessman. This businessman will take into parameter the var name and a var age of type int. Till now, everything is working fine. And I have here the functions talk and walk. Here, the business man is walking, and here is walking. Okay, if I go to the main function, and I can put here for the football player or the math teacher or the businessman, I can create an instance of them. So I will create teacher1 equal to teacher, and I will specify the name Jack and the age 29. Now t1 dot walk and talk, I can print them. So if I call the talk method inside the t1 object, it will give me the result that the teacher Jack is talking. Amazing. This is the result, and this is the expected result. However, since all the characters are persons, they can walk and talk. However, they also have some special skills. A math teacher can teach math, a football player can play football, and a businessman can run a business. You can individually create 3 classes who can walk, talk, and perform their special skills, as we have done here. Okay, so I copy the talk and walk methods the same way for the player and the same way for the businessman. In each of the classes, you would be copying the same code to walk and talk for each character. If you want to add a new feature like eat, for example, you need to implement the same code for each characters. This can be easily become error prone while copying and duplicating codes. For example, if I create here function eat, and print ln the businessman is eating. Okay, and I copied this function along with the for the player and for the teacher. Okay, and I teacher here. Okay, I change it. Suppose that I missed to correct this inside the player. So the eat function will give me, if I create a player here, please concentrate with me, var player1 equal to player, I will name John and age 20. Then p1 dot eat. If I call eat, it will give me that the businessman John is eating, and this is wrong because the John is a player. If we go to player, we see that there is an error. By mistake, I have missed this. So I want from you to understand, if you add more and more features, you are you will come exposed to errors, and your code will have more and will contain many errors. It would be a lot easier if we had a person class with basic features like talk, walk, and eat, sleep, and add special skills to those features as per our characters. This is done using inheritance. This is an example without inheritance, and these are functions, the common functions that are common between all the persons, the teacher, player, and the businessman. Actually, a teacher is a businessman. A teacher is a person. Player is a person. Businessman is a person. So using inheritance, now you don't implement the same code for walk, talk, or eat or other functions for each class. You just need to inherit them. This is done by creating a very important concept, which is the class, the parent class. Okay, so teacher, player, and businessman become the children of the parent class, which is person. I will create a new Kotlin class here, and I will try to make this. This will represent the parent class. In order to allow other classes to inherit from it, we start by the keyword open. Open class person. Here we pass the parameters of the constructors, and I will specify the var name as a string, and I can specify the age, var age of type int. Okay, so the person accepts the name and the age, and I will start by initialized, print the person, and here the name template is, or the person name like this, and the person age is like this. Okay, now I need to modify the other classes to tell Kotlin that, hey, the businessman, the player, and the teacher classes are inheriting from the person. So I will go to the teacher. I will remove this and here we put 2 dots or the semicolon, and we specify the class that we are inheriting from. It's of person, and we specify the parameters here, which are the name and the age. Okay, and we remove the variables here, the var keywords, and everything will be fine. This teacher class is inheriting from the person class. Now I can move all of these. I will cut them and I will move them into the person here, and here we can specify that the person is, or I can make like this, is walking and talking and eating. Okay, this is for the person. For the player, I will remove all of these in the same way. Var, I will remove these and put here the person class, and I will specify the name and the age. Okay, for the businessman also, I will remove these because they are common and we can inherit them all from the class person. Okay, so person, and I will specify the name and age. Now, if I go to the Kotlin, hello Kotlin KT, I can create var t1 or a player. I will remove this. If I run the program, everything is working fine. The person, let me put like that, these lines to be more pretty and easy to understand. Okay, if I run the program now, again, without changing anything, the person name is John, the person age is 20. These are initialized when we create a new person object, because we initialize these, and we print the name and the age. Now, when we call the method eat, then it will display for us eat function, but eat function is from the person, and we are calling p1, which is a player. But remember, a player is a person, so it inherits from the person the function eat, walk, and talk. So a teacher can do all of these three functions. The player can do them also, and the businessman can do these three functions. Okay, one thing I should remember you, that you should notice this open keyword before the base class or the parent class. It's important. By default, classes in Kotlin are final. If we look on the businessman class or player or a teacher, by default, classes in Kotlin are final. If you are familiar with Java, you know that final classes cannot be subclassed. So you can't create a class that inherits from teacher unless you put the keyword open. By using the open annotation on a class, compiler allows you to derive new classes from it. Okay, this is a very good example about inheritance in Java. In the next videos, we will continue with these examples and exercises to understand the inheritance, polymorphism, encapsulations. Hello, my friends. In this video, I'm going to talk about secondary constructors. A constructor is a concise way to initialize class properties. It's a special member function that is called when an object is instantiated or created. However, how they work in Kotlin is slightly different. In Kotlin, there are two constructors, the primary constructor and the secondary constructor. The primary constructor, concise way to initialize a class, while the secondary constructor allows you to put additional initialization logic. We've seen in a previous video the primary constructor, which is a part of the class header. Like this example, we have two arguments, the name and the age. So if I need to create a person, I should pass at first the name and then the age. So we respect the type and the order of these variables. Okay? These are the two properties. Now, the initializer blocks. The primary constructor has a constrained syntax and cannot contain any code. This is a very important point. To put the initialization code, not only code to initialize properties, initializer block is used. We've seen in the previous video how we used the init. It's a prefix with init, initializer keyword. Let's modify this code. This is initializer, println and println, and I will put here ln here, and I will use we used the initializer. Okay? When we run the program, I will create a person here inside the hello world, hello Kotlin, var p1 person1 equal to person, and I will put here a Jeff, and I will put here the age, and then if I click on run without calling any method, and we look on at the logcat, we see the person name Jeff, the person age 27, and we use the initializer messages are on this logcat. So init, these are executed whenever we have created an object of this person class. Okay, so the person class has two properties, the name and the age. When person1 p1 object is created, code inside initializer block is executed. The initializer block not only initializes its properties but also print them. Okay, this is how we use the initializers and constructors in Kotlin. I should mention a very important note here for the primary constructor, that there is a default value in primary constructor. So you can provide default value to constructor parameters, similar for providing default arguments to functions. For example, if I specify here for the age, I can make like this equal to 0. I can specify a default value for the age. I can remove the var, by the way. So if I create here, if I create here an object or an instance of the person class, and without specifying its age, I can check for it. For example, let me show you directly, p2 equal to person, and I put here a Jack. Okay, so p2 will give me that the age of Jack is 0. So the default value of the person 2 is 0 for the age. You see, we can put a default value for the parameters. Okay, now let's talk about Kotlin secondary constructors. In Kotlin, a class can also contain one or more secondary constructors. They are created using the constructor keyword. Secondary constructors are not common in Kotlin. The most common use of secondary constructor comes up when you need to extend a class that provides multiple constructors that initialize the class in different ways. Be sure to check a Kotlin inheritance before you learn it. Okay, so in order to create a secondary constructor, we start by the keyword constructor. Okay, and we should use it inside the inherited classes. So for example, we use constructors with that secondary constructors where there is an inheritance, and you don't have the primary constructors in the superclass. Okay, like this. I will remove this. The constructor here, I will start by name. It's of type string, and age of type int. Okay, this is the constructor, and we specify here the code of this constructor. Forget about these functions, and I'm just showing you the secondary and the primary constructors. Okay, if we open the player here, I should remove these arguments. Okay, these parameters. Also, I will remove this, and I will type the constructor for the name of type string and age of type int. And here we put super, and we get the name and age from the super class. Okay, and here we put the constructor of the the secondary constructor. This is the code where we initialize, like for example, we put here that we used the secondary constructor. Secondary constructor is being used. Okay, this is the secondary constructor. You should mention it when you have the inheritance and the parent class don't have the primary constructor. But this is not common in Kotlin. I want from you to understand that we use it, these type of constructors, the secondary constructors, for when you have an inheritance and we don't have the primary constructors, okay, in the parent class. Hello, my friends. In this video, I'm going to talk about super keyword. If the derived class contains a primary constructor, then we need to initialize the base constructor using the parameters of the derived class. If the math teacher class doesn't have a primary constructor but a secondary constructor instead, the secondary constructor can be preceded by the super keyword. The super keyword will call the constructor of the super or parent class to initialize the properties of the parent class. In this example, we have the employee here as a super class and the math teacher as a subclass. We see that in the super class, we have a constructor which took into the parameter the string as name and name as a string and age as integer. In the subclass, we don't have here, this is a class, a derived class, it inherits from employee. We don't have a primary constructor. We have a secondary constructor. It should, for the math teacher, if it doesn't have a primary constructor, but secondary constructor instead, this is a secondary constructor, the secondary constructor can be preceded by the super keyword. You see, guys, this is the name, this is the age, and this is the salary. But the string and age are inherited from employee. So we can put here the super keyword that contains the name and age, telling that these properties are inherited from the employee, which is the super class. Hello, my friends. In this video, I'm going to talk about getters and setters. In programming, getters are used for getting value of the property. Similarly, setters are used for setting value of the property. In Kotlin, getters and setters are optional and are auto-generated if you don't create them in your program. How getters and setters work. Let me show you an example. If I create a new Kotlin class here, I will name it as person. Inside this class person, I will create a var name of type string, okay, equal to Jack, for example. It's equivalent to this writing. So if I write like this, please guys, write this very important note on your copybook in order to memorize them fast later on. It's equivalent to, making this note, is equivalent to get equal to field and set, this is the getter. Let me mark it. And this is the setter, set value of the field equal to value. Okay? This is for the setters. Okay? When you instantiate an object of person class and initialize the name property, it's passed to the setter's parameter value and sets the field to value. For example, if I go to the main here, I will create a new person, p1 equal to, or var, sorry, we start by var, person p1 equal to person, and I will initialize it to Jack. Okay, here I can put the default value, or I can make like this, p1 dot name equal to Jack. I can use constructors, or I can access the field. Now, when you access the name property of the object, you will get field because of the code get equal to field. Okay, this is the field. This is how we access the field. Okay, you see how we set the value. It's passed to the setter's parameter value and set the field to value. And of course, if you want to print it, it will access this value and this field, and the name property of the object is accessed, so you will get the field because the code get equal to field. So we set the value here, and if I need to print it, we need to use this get method. Okay, so this is very similar, and these codes are auto-generated, so you can put them or you cannot because they are auto-generated. Okay, so if I run the program here, if I print p1 dot name, I run it. Here I am accessing, I am getting, I'm calling the get method. Here, when I specify and assign Jack is equal to the name of p1, then I am setting it. I am using the set value, passing Jack here, a field equal to value. Okay, so these are the getters and setters in Kotlin. Hello, my friends. In this video, I'm going to talk about visibility modifiers in Kotlin. Visibility modifiers are keywords that set the visibility, the accessibility of classes, objects, interfaces, constructors, functions, properties, and their setters. Let's talk about these keywords. There are 4 visibility modifiers: the public, private, internal, and protected. A package organizes a set of related functions, properties, and classes, objects, and interfaces. If we look here, there is a package. Okay, if I need to create a new, I can create a new package from here. So you can select new, I can create a package. Please bear in mind you can create packages, and I will show you later on. So we are on the app folder or a package, Java folder or package, com.mastercoding.hello Kotlin to package or folder. So think about a package as a folder on your computer. Okay, let's see and understand these visibility modifiers. The public. When you use the public keyword or modifier, you are setting the visibility to public, which means that the declarations are visible everywhere. If you use private, visible inside the file containing the declaration. Internal, visible inside the same module, a set of Kotlin files compiled together. Protected, not available for packages, used for subclasses. Don't worry, we will see them in more details. Okay? And note that if the visibility modifier is not specified, it's public by default. So at the level of packages, public is visible everywhere. Private is visible inside the containing folder or file. The internal is visible in the same module, and protected is not available for packages. Okay, we don't use protected for packages, it's used for subclasses. We can use these for at the level or inside classes and interfaces. So when you see public, private, protected, internal keywords inside classes and interface, you can think about these as public, visible to any client who can see the declaring class. Private, visible inside the class only. Protected, visible inside the class and its subclasses. Internal, visible to any client inside the module that can see the declaring class. Note, if you override a protected member in the derived class without specifying its visibility will also be protected. Let's take an example. If I open the person here, person class that I have created in the previous video. If I specify var name, okay, I will remove these getters. If I specify here and I create an object, an attribute of var and name as its name, var a equal to Jack or var name equal to Jack, it's public by default. So this is a public, so it's visible to all the classes. Okay, so I can access it, or I can put like this. So it's similar to using this naming and using the public keyword. If I create private age, private var age equal to 2, okay, it's private. Okay, so private to base class. So if I go to here, into the main, I create a var person1 equal to person, and here p1 dot, you see guys, I can only access name because name is public. I can't see age because it is private. Okay, I can use protected var hair color equal to black. So this is declared as protected. Protected is visible to the base and the derived classes. So if I create here a new class, I will name it as teacher. So if I extend it, I will create a constructor here. Let me make, I can derive from the person directly. From the person, I should make it open. Okay, so what I will make here, I can print ln person, or I can make like this: name, age. I need to override before printing. Override using overriding. We'll see it later on. So override, I'm taking the control to make a new change for this value. Var of name. So if I click on Control and space, or you can put NA, it will display for you. This is the parameter name that it's inherited from the parent class, which is name. Okay, so person name is inherited and overrided here. If I click on Alt plus Enter to change the typecasting to the string, because this is a string, and override, I need to make person var as open. So open class and open var in order to override it. So the name now is Johnny. Okay, you see, I can access access this variable because it's open and a public. Okay, so the public, which is the visibility modifier used here, by default, I can access it in the subclasses. Okay, so if I print now the name here, if I put here override var age, it will not appear because age is declared as private, and private is only visible inside this file. Okay, and this class only. If I put here the hair color, okay, it's of type string equal to gray, it will give me Alt plus Enter. I can make it as open. So you see, I can access the protected attributes, the protected visibility modifier, declared variables inside the class and its subclasses. If I declare internal, so it will become invisible to any client inside the module that you can see declaring class. So here I will create internal val d equal to 6. I can modify it inside other subclasses or inside the hello Kotlin. I can access it because you can see p1.d equal to 9. These are the visibility modifiers These are how the ways that we can access and how to prevent and how to set the accessibility and how to prevent other classes or other modules or other packages from accessing our class attributes and functions and interfaces and others. Hello, my friends. In this video, I'm going to talk about a very important concept in Kotlin, which is abstraction. Data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. In this video, I'm going to talk about abstract classes, and in the next video, I'm going to talk about interfaces. Like Java, abstract keyword is used to declare abstract classes in Kotlin. An abstract class cannot be instantiated. You cannot create objects from an abstract class. This is very important note. So you can't create objects from an abstract class. However, you can inherit subclasses from them. Okay? The members, properties, and methods of an abstract class are non-abstract unless you explicitly use abstract keyword to make them abstract. Let's take an example about abstract classes. In this package, I will create a new Kotlin class. I will name it as a person. In the same example as before, I will create a class here called person. But here, I will create it as an abstract. So I use the keyword abstract to say that this class person is an abstract class. Okay? So inside this class, I can create variables and other methods like a normal class, but there is a very important difference is the abstract keyword, the abstract functions that I can create in this class that force the children, the subclasses of this class to inherit and implement them. We will show everything step by step. No, don't worry. Please, guys, follow me. Int var of age equal to 30. I will create this age. And function display age. I will display age. I will print ln my age, okay. My age is, I can make like this. I use templates, string templates here, okay. Now, the very important difference between abstract classes and the other classes is the abstract functions. So I can declare abstract functions, abstract fun, display welcome or display greetings. This will not accept the body of a method. Okay, so if I hover here, a function display greetings with body cannot be abstract. So either you create a body and you remove abstract, or if you want it to become an abstract and keep it and continue as an abstract class, you need to remove these curly braces. Okay, so an abstract function is a function without a body. Okay. So this abstract class person is created. You cannot create object of this class. If I go to here, to hello Kotlin, this is our testing file. If I start to create a person or var1 var p1 equal to person, okay, so it will display for me an error telling me that cannot create an instance of an abstract class. Okay, I can't create objects of this abstract class. The class has a non-abstract property, which is the age, and non-abstract method, which is the display age function. If you need to override these members in the subclasses, you should be marked with open. So if I need to override them later on in the subclasses, I need to put open here. The class has an abstract method called display greetings. It doesn't have any implementation and must be overridden in this subclasses. Okay, in subclasses. For example, if I create a new Java class here, I create new Kotlin classes. I name it as a teacher. Okay, and this teacher, it took into the parameter name and of type string, and here it will inherit from a person. So there is an error. If I hover here, it will show me this message. Class teacher is not abstract and does not implement abstract base class member display greetings. Okay, so I need to implement this function. Implement members, click on it and click OK. And here we go. We override the display greetings method that it's declared as an abstract method inside this abstract class. Okay, so think about abstract as a force to implement the functions. If you are creating a very big class here, and you should implement some important functions, you should declare them abstract in order not to miss them into the subclasses. Okay, so a class teacher is derived from the person abstract class, an object of here I will create it like this, var p1 equal to teacher, and I will pass the name of this teacher as Jack. p1 dot, you see it inherit the age attribute, it inherits the display greetings function and display age function. Okay, I will display greetings. If I run the program, it will display for me a hello teacher method, because it forces this abstract class, forces all of its children, all of its subclasses to override the display greetings. Here I should print hello teacher. I run the program again, and here we go. We are calling the function that it is an abstract and declare an abstract inside this abstract class. Okay, so non-abstract functions are not obligatory to implement them in the subclasses, while the abstract functions are very important, and you should and you must implement them inside the subclass, and otherwise it will be displaying an error for you. So this is the abstraction in Kotlin. In the next video, we're gonna show you a very important concept of abstraction, which is interfaces. Hello, my friends. In this video, I'm gonna talk about interfaces. Kotlin interfaces are similar to abstract classes. However, interfaces cannot store state, whereas abstract classes can. Meaning, interfaces may have property, but it needs to be abstract or has to provide accessor implementations, whereas it's not mandatory for property of an abstract class to be abstract. And we have seen this in the person abstract class. we said that these are non-abstract, and they can be like this, and you can write these codes without using the abstract. While if we use the abstract keyword, we should implement it. We are forcing the subclasses from person class to implement and override the declared functions as abstract. Okay, so let's take an example about interfaces. So abstract classes in Kotlin are similar to interface, with one important difference. It's not mandatory for properties of an abstract class to be abstract or provide accessor implementation. We will see that the interface is mandatory implementing all its functions. Okay, let's create an interface. Here I will create new Kotlin file. I will select Kotlin interface, and here I will create a vehicle. This interface vehicle will have has this variable. I will make it like this, or I will change the speed value equal to, or it's of type int, or I can make it like this. Okay, function start engine. Okay, and function accelerate. Okay, this accelerate function will contain will increase the speed or print ln. I will display message just for demonstrating accelerating. Okay, so please pay attention for me. When I'm coding here, I didn't use the abstract keywords. Okay, I'm just creating two functions, and here I am using two functions without any keyword, an ordinary function. Okay, I will add this body here as starting engine in order to display what's happening to the objects that we will create. Okay, so if I go to here and I will create a new Kotlin class, I will name it as ka, and this ka will implement the interface vehicle. So I specify this. I don't specify like this because it's an interface. I don't put here the parentheses. If I hover here, I have this message telling me that the class ka is not abstract and does not implement abstract member speed value that it's defined inside the vehicle interface. So if I implement as constructor parameter, I will click OK and everything will work fine. Okay, so you should implement these values here and override the value speed, and here, or I can remove this and I can override it here. Okay, override val speed. Okay, I'm overriding it, int equal to 25. Okay, you can override like this. Think about the start engine and accelerate functions. If I remove these and I put 2 points string, so I'm telling that I need to return a string. So here there is an error. If I hover again and see what's the error, car class is not abstract and does not implement abstract member, which is the function start engine. If I click on implement, I will need to implement the start engine and override it in order to get everything working fine. Okay, so this override function start engine string, turning string, it will return starting the engine. Okay, so whenever you don't specify what is the function, if you don't specify the body of this function, you are forced, you are mandatory implementing this function inside the subclasses or the classes that implement this interface. So if I remove the body of this function and I don't put any returning type for it, it will display for me in the class car, which implement the vehicle interface, an error telling me that I should implement the method accelerate. So again, guys, implement the members, accelerate, and here we go. We should accelerate. We should implement the accelerate function because it doesn't have here, it doesn't has any body inside this function. Okay, so whenever you specify the body of the function and you type the code here, you are not obliged and you are not forced to implement this function inside the class car. So whenever you see these curly braces, you are not going to implement this function in the subclasses or the classes that implement this interface. Okay, this is a very important note. So I will not implement this function. I will put like this, print ln accelerating. Okay, so if I create a function here, or I call the function from the variable vehicle or car, c1 equal to v equal to car. I can't create an object from vehicle. c1 dot, you see guys, the accelerate function, and I will call the other function, which is start engine. Okay, let me run and see. And here we go, we are accelerating. If I go to the starting engine, return starting engine. Okay, I need to put here inside print because it will return a string and not display a string. Okay, and here we go, we are accelerating and we are starting the engine. Okay, so guys, I want from you to understand this very important concept. Whenever you see a curly braces here, block of code, so you are not forced to implement this function, to override this function in the classes that they implement this vehicle interface. Whenever you see like this, or whenever you see like this without the body of a method, you are forced to implement this function in your classes that implements this interface. Okay, guys? This is the interface. Hello, my friends. In this video, I'm going to talk about Kotlin nested and inner classes. Similar to Java, Kotlin allows you to define a class within another class, known as nested class. So, for example, I will create a new Kotlin class. I will name it as outer. And this class, this is the outer class. I can create here some functions and some variables here. Okay, I can create an nested class or inner class. Okay, so I can start by class keyword nested. Okay, and now I can create here the variables and the functions of the nested class. Since nested class is a member of its enclosing class outer, this is the outer, you see, these are the curly braces. So then the class, the nested class is included inside these parentheses. You can use the dot notation to access nested classes and its mapper. For example, if I create here var age equal to 25, and inside this nested class, I will create length equal to 55. If I go to hello Kotlin and I create a variable o1 equal to outer, I can put o1 dot age. Okay, this is how we can access an outer class. But if I need to access this length, I need to create like this: var nested equal to outer dot nested, and now I specify the constructor. Now nested dot length property will be appearing here. Okay, so I'm creating an object of the outer class to access its age, and here I'm creating an object of the nested class outer dot nested. You see, I'm using the dot in order to access the inner class, okay, or the nested class. Okay, this is how we access the elements of an inner class or the nested class inside an outer class.